So right now we'll see the flow as a student when they joined in the engineering, and it will be connected towards what they have to do in the industry, VLSI industry. So this is the flow where EC is basically has two streams. One is electronics and another one is communication. So when we go through the electronic stream, the student when they're in the first year, because of lack of proper basics across the electronic components, what they need to do is they will be going through the basic components like resistor, capacitor, inductor, diode, transistors. Right, these are the transistors they will be learning over here in their curriculum. So these two, as per the industry, they will be learning it later on. So once they are comfortable with the basics, the basic properties of the electronics and characteristics of the electronic components and devices, what they know, once they are comfortable with that, they will be going with the second phase, where in the second year they will be start constructing an electronic circuit by combining that components like resistor and capacitor will be one form of the circuit, and a capacitor and along with a diode, and they will be connecting on circuit. So simple circuits like wave shaping circuits and half wave rectifiers and full wave rectifiers, this kind of circuits will be made over there. And using transistors they will be making amplifiers. So once they are like designing simple circuits throughout like second year of their btech, they will be knowing that up to some extent where they can do the construction, they construct a circuits. But the problem is when they wanted to be in the industry, they need like some kind of skill that millions of transistors need to be connected on the single silicon substrate. Means like they have to make a IC. So for that, the manual way of like connecting the components on breadboard for simple circuit construction, that will not be possible, will not be suitable, right? So for that, like they have to uh, adapt some kind of methodology where like they have to take assistance from the CAD tools, where computer aided design tools, with the help of them they will be constructing all the circuits. If it is a integrated circuit, if it is a complex circuit where millions of transistors are there embedded on one IC, right? For that, there are like multiple vendors we have it in the market. One is National Instruments NI, and Mentor Graphics and Synopsys and Cadence. These kind of vendors, what they provide the tools. With the help of them CAD tools, what students do is they will be designing every circuit, they will be making every circuit on that particular CAD tool. So the CAD tool is going to construct that particular layout and making like some kind of IC design flow. Everything will be the CAD tool, will be done by the CAD tool. So this is the total flow that from the first year to third year that as a electronic student will do. And finally after like he get a proper skill of like designing integrated circuit, they will be start doing the project. So where like in the project they will be developing some kind of application where which will be treated as a complex one. So with the help of that knowledge, they will be going through that industry where they can be suitable for like any kind of role in the industry. These are the list of roles that we have from this point to this point. There will be there will be different domains where like the electronic student can fit over there. So as electronic student, where he can construct a integrated circuit, simple one, right? Now when he is entering into the industry, he has to suppose to design integrated circuits, which is complex one. So now when they're in the project, as we know, like around 10 students are there working in the project, they all together will do the design of integrated circuit. Design will be done by the 10 people for sure, that is okay. But like each student will not all students will not do the same task. There will be a partition of that particular project, and some module will be done by like a few of the students. As like a project is done, the same way here we have like multiple domains where the initial stages of the chip design will be done by some engineers, like few engineers, like those are called front end engineers, where like RTL design engineer will be a first one, right? He will be taking care of like start doing the design of IC. So what RTL design engineer do is they will be start writing the code, vanilla code, for the specification given by the user. So the specification, if it is like in the form of like oral description, right, he has to convert into the form of like standard form, where in truth table or logic diagram and boolean equations, right? So based on that they will be constructing integrated circuit by writing the HDL code. So RTL engineer will be taking care of that. And after that, some other person, right, called verification engineer will come into the picture. He will, as per the specification, is that particular module which is designed by the RTL design engineer giving the output or not, will be verified by the verification engineer. And as the verification engineer has complexity up to some extent, where like a number of inputs for the digital circuit, if it is less, he can make like test bench and he can test it. But if the design circuit is complex, if the design circuit is complex, where it need to be simulated through the test bench, which will be a complex, then they adopt like UVM technique there. Universal verification methodology will be adopted over there to do the testing. And after the testing is done, right, the module is verified properly, the simulation is done properly, they will be going through the phase called synthesis, where in the synthesis process they will be converting that code, RTL code, into the gate level netlist. RTL schematic will be generated. So this entire thing is called like front end design process, like where the chip design process, where we have it from the first point to the last point, like some part where like from the simulation, from the RTL design and simulation and synthesis, these three comes under front end design part. And after like front end design part is completed, they will be going through the back end process. Whatever that gate level netlist we got it, that will be forward to do the rest of the people, that there is another team is waiting for doing the rest of the process called back end process. So where like a physical design engineer will be taking care of like uh, like multiple modules which were constructed in the first phase need to be placed accordingly on the silicon substrate is available. The placement need to be done. After that, routing need to be done. Clock tree synthesis need to be done. So all the steps need to be done one by one. That will be done by the physical design engineer. And after the physical design engineer place that all the modules and which will be accommodated with the IC, that proper module which is ready, and that module need to be verified with some kind of timing analysis, through that timing analysis. So is that particular module will be giving the proper timing constraints, like meeting the timing constraints or not, like it has to be verified in the next phase. And after that, the physical verification need to be done. The verification process which we have it, that need to be done in three phases. Like in the first phase we have to do that verification for once, and here also we have to do the verification. In the third time also we have to do the verification at the end. So we have to do it for 3 times. And after the verification is done, the layout will be ready. That layout we have to send it for the fab industry. That fab people will be making that particular layout as per our requirement. So this is the entire process from the first step to the last step, from here to here. So entire process will be done, right, from the engineer point of view. After the layout is made, like layout will be sent to the fab industry. That process will be fabrication process. That fabrication process will be done from the industry, from the fab end, right? So here there is another engineer called FPGA design engineer. He will be taking care of designing that same module on the FPGA. So where we have the problem with designing through the fab is that it is a long process, where sending that layout to the fab, and as per the constraints, as per the requirements, that like making that layout, it will be a costly process. Making that IC is a costly process. So to avoid that, when we need a specification need to be ready within no time, I can go with the FPGA. So where like I have FPGA design engineers will take care of that. Whatever the synthesis design that we have it, the synthesis design directly we dump it to the FPGA. So that FPGA module will be ready with whatever the specification that IC we are expecting. That IC will be now ready with the proper specifications across the FPGA. So this is the entire process from the beginning to the end. At the end, like we can use that IC wherever that application we have, that where across that our FPGA kit, that we can use it over there. So after that, we can see that some of other engineers also will work over there on IC design, mixed signal and analog design engineers. This will be another domain where like we can see IC will not have only digital modules. There will be a combination of the analog modules also. So analog modules along with the digital modules combinedly, if you have that, we can call it as a mixed signal IC. So there, like a mixed signal IC design along with the digital circuit which we have designed, we need to keep like analog circuit also there, and need to be providing a compatibility with the analog and digital circuit. So where like I have to recruit some kind of people where like they can do the analog design. After like they do the analog design, they will be connecting that analog circuit to the digital circuit which already made. So that analog and digital circuit design total combinedly we call it as a mixed signal design IC. That IC need to be made by the mixed signal design engineer. And after that there will be some other engineers called DFT, design for test engineers. Like the design which we have it, we have to go with the fabrication. After the fabrication process is done, we have to make sure that the design need not to have any fault free device. So for that they will be keeping some extra module, analog module, along with the digital module there will be a built-in self test module also they will be connecting, right? That built-in self-test module, what that it will do is it will be checking the functionality every time by generating a scan chain. So there will be a test pattern will be generated every time, right? That will test automatically, will make sure that whether that fabricated device after the manufacturing, whatever the device is made, is it functionally correct or not, is it gives that proper functionality or not, like it will be verified at the end. In the same way, like verification engineer and validation engineer, that it will be like those will be verifying the functionality of the entire design module after the manufacturing once again, right? Visit that module will meet the specifications as per the user is given. So the initial step where like the design is when it started there itself, like user will give the specification. As per the specification, whatever the IC is made, this IC meets the requirement of that user or not. And as per the timing constraints are not or meeting or not, like it has to be verified by the engineer called the verification and validation engineer. So this is the complete process of like designing a integrated circuit where like each and every phase where some few of the engineers will be accommodated out there, few of the engineers will be recruited out there to do their job.